Remember that this session is being recorded and will be available to watch on demand following the conference. If you have any questions during this session, please add them to the Q&A. You can find that tab to the right of your screen. And also note that your questions will be private. And with that, I'd like to introduce our speaker. I'd like to welcome Stefano Sarasso, CEO of Ubiquicom. He'll be speaking about asset tracking and smart safety technologies and how electrification can leverage these technologies to deliver added value. I will note Stefano's presentation dovetails nicely with the trend line that our keynote speaker indicated on digitization trend and how that's dovetailing with electrification. So thanks for being here today, Stefano. Please go ahead.
Thanks, excellent. So everybody, I'll be talking to you about asset tracking and smart safety in electrification. My name is Stefano Sarasso. I'm the CEO of Ubiquicom, an Italian-based company which deals with real-time locating systems. Couple of words about me. I have an engineering degree. I've been in the past. I've been working in consultancy for about 15 years before founding Ubiquicom. Ubiquicom is based in Milan and specializes in real-time locating and tracking systems. The acronym for that is RTLS, and we focus on efficiency and safety of industrial processes. And we primarily target the manufacturing, transportation, and logistics and supply chain market, as well as agriculture and facility management as clients. Ubiquicom, as I said, works with RTLS, real-time locating systems. We have unique patents on real-time locating system technology. We have products based on those patents and our know-how and deep know-how on real-time locating system technologies. And we also have location-enabled product and applications that leverage the location awareness of our products to serve our customer base, which is mainly OEMs, large dealers of industrial machinery, and corporate industrial end users such as big logistics players or manufacturing clients. With that said, topic of today is mainly how asset tracking and safety can help electrification, can leverage electrification to help end user clients get more in terms of efficiency and safety. Traditionally, efficiency and safety have been two words that don't really get along very well, especially because a very safe process is typically thought of as an efficient process, as well as a very efficient process is thought of as a potentially dangerous process when things move fast or heavy machinery is involved. What we're trying to do with our technology is to make sure that those two words get together, so efficiency and safety can be productive at the same time and can help the same process be safer than it was and still be efficient and guarantee productivity. So the same technologies, as you can see from the rest of the slides, can be made available to provide both of those worlds. First of all, I'd like to apologize. The PowerPoint you see is full of the Ubiquicom brand. There's a lot of quotation about our products. Point is, in order to make you understand exactly what those products can deliver, the easiest way was really to talk about our product base rather than being very generic. And so for the sake of everybody's understanding, we have used some slides that are really focused on our product base. So I apologize for that. Of course, it's a bit of marketing on our side, but hopefully that will make you understand perfectly what we're trying to convey with this presentation. So in Ubiquicom, when we think about digitalization as an ecosystem of products, there's many things that clients, both the end user level or OEM level, might need from digitization, and we're trying to make so that clients can buy products and services at a modular level, but can also benefit from coexistence of those products and the fact that those products can work together. So we have an ecosystem, we call it Ubiquicom Industrial Machinery Product Ecosystem, and it's made of 5 pillars at the moment, one being telematics with our product called Track Vision. Second one would being safety, and we're going to talk about that very thoroughly in this presentation. Third one is being process efficiency through our real-time locating systems and products. Fourth one being location-aware warehouse management system optimization. So we help warehouse management systems work in an optimized way by leveraging the location information by an application such as Synchro. We're going to talk about that. And also we provide remote diagnostics for our machines. The point is everything is actually based and focused on industrial machinery, which is at the center of this ecosystem. And again, for the sake of clarity and simplicity, we're going to talk about this based on forklifts today. So you're going to see a lot of examples talking about forklifts, but of course, the machine can be any industrial machinery, can be applied to agricultural situation, can be ports, can be reach stake, it can be any industrial machinery that is linked with asset movement and productivity. So with that said, as I said, we're going to talk about mainly 2, 3, and 4 of this chain today. I'm going to tell you a bit more on how safety and process efficiency can get together. But I want to mention that the way we provide those safe and efficient processes is very often based on the way we deal with also telematics, because our telematics offering is based on what we call the Track Vision blue box, so a box for telematics, which is at the center and the core, also providing safety and safe processes, as well as provide location-aware machine movements that can be tracked by our location engine. So the telematics box can be used not only for telematics and telemetry, but also for these other functions on 2, 3, and 4. You see it during the presentation. That's Track Vision, as I said, our telematics offering, very, leading edge, modern telematics system that can be applied to specifically to material handling and agricultural industries. The Industry 4.0 paradigm is inserted into that, and we have integrated the telematics platform with CRM, MES, warehouse management system, MRPs. So it's a fully integrated solution. We're not going to talk about this today, but just to mention that telematics is also part of the ecosystem and can be leveraged to provide safety, location aware, and all the topics that we're going to talk about today. So let's dig into the first topic of today's discussion, which is safety. We think of safety as, of course, a very important part of the industrial processes. And we know that the digitization technologies and digitalization can be made at work in order to provide safer environments. Specifically, the solutions we provide enable locating, monitoring, interacting with operators in real time, verifying their health status, both indoor and outdoor. And also we apply safety paradigm to machinery and specifically to moving machinery, forklifts, for example, to provide a reduced risk of collision, man-down events, monitoring, and helping avoiding collision between machines and between a machine and a walking pedestrian or a machine and a fixed obstacle. So our concept of safety is really by applying digitized products to both working personnel and working machinery in order to provide a safer environment. With that said, I'd like to show you a very quick video. Just hold on with me. I'll share a video file. You can tell a bit more about
central issue in material handling activities in logistics and manufacturing. New technologies increasingly provide effective tools to prevent accidents and limit injuries. Ubiquicom has developed the only integrated solution for collision avoidance and personal safety by exploiting the most advanced locating technology to increase safety without impacting efficiency. The proximity system, thanks to ultra-wideband technology, is capable of continuously and accurately calculating the distance of a vehicle from people, other vehicles in motion, or fixed obstacles. This way, the system keeps track of moving vehicles by identifying risk situations. Furthermore, proximity makes it possible to run automations with great efficiency and accuracy. If necessary, the device on board the vehicle intervenes by alarming the risk to the driver and slowing down the forklift. Wearable personal tags provide vehicles to detect the presence of people and to generate alarms and forced slowdowns in the case of excessive approach. With the Ubiquicom Locator software platform, it is also possible to monitor the position of vehicles and people both inside and outside the production areas and warehouses in real time. This functionality enables the advanced management of man-down events and many other situations related to the safety of the area. For example, the risk initiated from the presence of people while a stock operation is in progress on the opposite side of a rack. Furthermore, by using software, it is possible to dynamically configure areas and time slots in which the speed must be limited and apply these limits to the vehicles without intervening on the vehicles themselves. The top-of-the-line Proximity Plus system is able to accurately measure not only the distance between people and vehicles, but also the arrival direction of the potential risk. Proximity Plus is therefore able to distinguish dangerous situations from those that do not involve risks, and therefore do not require the generation of alarms or speed slowdown. The Ubiquicom Safety Ecosystem. Maximum safety with a single integrated solution for people and vehicles. Ubiquicom. The innovation beyond location.
So the idea here was to make you understand a little bit how we talk about digitization in terms of interaction with electrical system. As you can understand, and hopefully you'll see my presentation back now, yeah. The way that those systems can interact with an electrical machine are far more efficient than the ways that those type of electronic systems can interact with an engine machine or with a thermal engine machine. So the fact that digitization goes along with electrification is clearly a benefit of the way that those safety systems are integrated with the machine. Let's get more in detail about this. Those safety ecosystems can provide the following 6 main functions to an end user. First of all, collision prevention. You've just seen some examples. The idea is that by just detecting each other, 2 machines can prevent colliding. And so possible very dangerous situations can be avoided and prevented. Second is accident detection. We can get to the point in which we know there's an accident by the sensors on board our telematics system, so we can detect the shock, the accident, and the detection can be communicated centrally to the telematics system, the telematics platform, and can be reported, can be statisticized, so we can have data about accidents and where they took place. Third one is so-called zoning. Zoning is a feature that allows some particular spaces within the working environment, for example, the warehouse, to be devoted to reduced speed. So we can, by knowing the exact location of the moving forklift, we can tell the anti-collision system to reduce the speed of the forklift by interacting with the electrical system of the forklift. Then again, you see where the electrification can leverage those kind of technologies. we can also have advanced rules for slowdown. So in the same way that zoning works, we can make those zones or some zones work dynamically, and for example, enforce some specific slowdown or reduce speed enforcements just in the presence of some other workers, or for example, just in some specific time frames where, for example, some specifically intense operations take place. We can also have man-down alarms for people. So the same type of tags, hardware tags that are worn by people to interact with the anti-collision systems on the forklifts can also be used to detect man-down situations. So when somebody is not feeling well, can also be detected. And all of these, point 6, will provide an enormous amount of data that can be collected to the risk assessment activities and reporting. So all of that is devoted to safety, but at the end of the day, is also a very large mass of data that can be used to do to drive some management decisions. So, in detail, collision preventions, our systems, and we're not the only one, of course, in this market, but our systems are very advanced to that extent, can implement vehicle-to-vehicle, vehicle-to-pedestrian, and vehicle-to-fixed obstacle safety by providing a way of preventing accidents between a vehicle and a pedestrian or a fixed obstacle or another vehicle. We can drive the automatic slowdown of the vehicle, and all of that is based on a very advanced ultra-wideband technology that can measure the position of a relative obstacle with a precision under the 30 centimeters accuracy. So very, very precise and very frequent, because we have an update of the relative position between a moving vehicle and an obstacle 10 times per second. So we can be very effective. And of course, the configuration tools are very easy to use. Accident detection is done, as I said, by making use of the telematics box that can sense, by its sensors, can sense a shock over a certain threshold and communicate that towards the telematics platform, so that accidents or near misses, as they're called, can be reported. For example, we can enforce to limit the speed of a vehicle after a shock has been detected over it, and just authorized personnel can unlock that vehicle if a shock has been detected. The zoning feature I was telling you about is basically a way to provide a geographical zone which can be defined over a computer interface, so it can be updated and edited runtime in order for having a static situation in which the presence of a forklift will enforce a slowdown for this forklift, or can be dynamic. So it can be based on environmental conditions or specific situations over time that can change the way that dynamic zone will impact on the forklift behavior. Also, we can use zones to define evacuation and mastering procedures. Same thing, as we use zoning, we can also define advanced rules for slowdown. We can, for example, have the vehicle slow down in specific areas, but only if in that area there's at least one pedestrian doing their activities. So, as you can see, it can be very, very, very customized in the way you deal with your safe processes, because of the fact that everything is digitized, so it can be dealt with as we deal with any configuration on our computers or on smartphones. Man-down alarms, as I said, it's part of the sensors that the personal tags worn by pedestrians can provide. So in case there's a man-down detected on that tag, the tag will communicate an SOS to the system, and people can intervene to help out the pedestrian. And as I said, also we have data collection for risk assessment. So all of this will cause a lot of data flowing in the system, near misses, location of, for example, a very good explanation of what that reporting can help is the fact that if very many near misses happen at in the same corner or in the same spot of a warehouse, then there's probably a layout problem there. So the fact that there's a high density of near misses in a specific spot would probably trigger some management decision in terms of reviewing the layout of the processes in order to reduce the intensity of the presence of vehicles and people in that specific spot. And also the interesting thing is that you can also monitor the vehicle diagnostics parameters via CAN bus. Of course, that needs integration with OEM, OEM R&D, but that can be done and can be communicated to the telematics platform. We have several products in the safety ecosystem. Proximity is the basic one, can be used for small machines. It basically creates a bubble around the machine, so very basic type of detection. Proximity Plus is a more advanced situation, whereby not only the distance of the obstacle, but also the angle of arrival of the obstacle can be detected. And Third Eye is the most advanced system. We have a lot of patents around that, and can provide very precise detection of obstacles. And we're going to go through that in the next slides. It's based on ultra-wideband angle of arrival technology, and it provides the possibility of configure variable geometry alert and alarm zones around the machines. Also, it can be integrated with CAN bus of course, working with the OEMs. And that's a very important point because it can leverage the information about the vehicle status and route in order to provide a very precise safety warnings that will make the processes very safe, but at the same time will be very efficient in terms of productivity, because this integration will provide a very minimal false alarms to the system. That's another way of seeing the different approaches that you can see in the different systems. Proximity is a very basic one, a bubble. Proximity Plus will define a very detailed geometry around the machine, and Third Eye will provide not only a geometry around the machine, but it will also provide an integration with the route and the direction of the trajectory of the machine. So it will make a difference between an obstacle being on the right and on the left based on the trajectory that the machine is taking. So let's get a little bit more onto Third Eye, which is the most advanced system. As I said, it's based on a couple patents that we have developed and filed in the past. And the collected information is made available not only to the anti-collision system, but to the machine itself. So the machine control unit can design, integrate value-added functionality and reduce false alarms based on the information coming from the anti-collision systems. We'll get to a couple of examples in the next slides. The system is very versatile and can be applied not only in logistics, but also in mining, airport operations, constructions, agriculture, and other industries. So the way it works, the method of providing collision detection is the calculation of the position and the trajectory of the obstacles with the ultra-wideband technology. That will provide 25 centimeter position accuracy, more than 10 times per second. The typical range that the system will detect obstacles is about 25 meters. Of course, thresholds can be defined. A typical way of defining thresholds is define a warning threshold. So a threshold whereby obstacles within that distance will provide the driver of the forklift in this case, or the machine in this case, will provide a visual alarm. And if the alarm threshold, so the closer distance than the warning threshold would be passed, then the anti-collision system can trigger actions on the vehicle itself by, of course, communicating with the CAN bus or with the speed reduction relays present in the machine, whereby providing a way of slowing down the machine in a potentially dangerous situation. The benefit of a third eye is that you can define graphic alert and alarm zones to reduce false alarms and detect risk situations only. In order to do so, you can see the example on the bottom part of the slide. A machine which is moving and driving towards the right will see that the pedestrian on the right side as a potentially dangerous situation, whereby another pedestrian on the left side, which is not impacted by the trajectory of the machine itself, will not be seen as a danger. So the machine will slow down just in the presence of the person and the pedestrian on the right, but not in the presence of the pedestrian on the left. As you can understand, this will provide full safety by not impacting, while still not impacting productivity, because the unknown danger will not trigger any reduction of speed or any reduced operations and productivity. So that's the idea of our safety concept: provide full safety without impacting productivity. And you can do that with very advanced digital technologies such as ultra-wideband, and the approach of having ultra-wideband sensors integrated with the machine data, for example, coming from CAN bus, that can really leverage very detailed situations. Just to say on another example, we've shown a demo whereby a machine which is being turned on but still standing still will trigger a visual alarm if the steering wheel is geared towards the left, because in the left there's an obstacle, but will not trigger any alarm in the same exact position if the steering wheel is geared toward the right, because there's no obstacles on the right. So it can be very, very detailed, and there's no systems out there that can feature such integration. So very powerful integration that will provide productivity in a safe environment. That's again a slide that will provide some examples of what I just said. You can see on the top example that two machines colliding will, of course, provide an alarm, whereby if one of the machines is actually turning right and will get away from the route of the other machine, that will not provide an alarm. It can, for example, just be a warning for the truck drivers, but it will not slow down the machine. Same thing on the bottom part of the slide. You'll see a situation with pedestrians. So in the first example, the pedestrian is just in front of the machine, and the machine is driving towards that pedestrian. So that's an alarm situation, whereby the machine is actually turning left. Then the pedestrian will not be in the same trajectory of the machine, and the pedestrian is just a warning situation, but no slowdown needed in that specific context. So the strengths of that kind of systems, it's integrated with our TLS technology. So not only we know what's around, but we can also know where the machine is, for example, in a warehouse, and provide, as I said, near misses statistics, because the machine position together with a risky situation detected by the anti-collision system can provide statistics and a lot of business intelligence about the layout of the warehouse. At the same time, the real-time locating systems can also provide a way to slow down the machine independently from the presence of other obstacles, such as pedestrian and other fixed obstacles or other machines working, just for the fact that they enter a specific zone. So there's a geofencing function whereby if a machine enters a zone which is potentially devoted to some manual activities by with the statistical presence of a pedestrian, that is a slowdown zone, and it's a reduced speed zone. So the machine speed will be reduced no matter if there's a presence of a pedestrian or another obstacle in the zone or not. Of course, it uses ultra-wideband technology, very precise radio technology, safety configurable areas, so very detailed way of configuring the system in very many different use cases by different users. An interesting situation that can be, for example, configured is the fact that the detection zone is very much aligned to very fast operations when a forklift moves in a fast lane in a warehouse, whereas if the forklift approaches a crossroad in the warehouse, then the crossroad will be detected as a specific zone in which the detection areas configured for the anti-collision system will widen and consider not only the obstacles ahead of the machine, but also in the left and right sides of the machine. So it can be dynamically updated as the operations flow during the day, so that you can provide maximum safety in dangerous zones and then maximum speed in the situations in which there's no potential dangers around. The situation is compatible with any industrial machinery, and of course, a vehicle mount computer can also be integrated with the system in order to provide the driver a lot of information about the surrounding potential obstacles. I'll skip on those. It's just very quick overview of the items of the system components. You see on a personal tag on the right and the vehicle components on the left. There's also self-check station. Pedestrians entering an area which is equipped with that kind of anti-collision system will check if that tag is operational before entering the area. So the self-check station can, for example, drive access control to the operational area, and also the vehicle mount computer you see on the right side. As I said, the third eye anti-collision system can be applied to many different types of industrial machineries. We talked about forklifts, we talked about wheel loaders, but you can have a lot of very many different situations in both constructions, logistics and warehousing, airport operations, iron and steel industry, agriculture and mining. So all of those industries can benefit out of that type of anti-collision detailed system. Again, point here is that the anti-collision system is able to detect obstacles, but the fact it can be integrated with an electrical system and talk with that electrical system data with the CAN bus can really unleash a lot of potential on the anti-collision system itself. Again, steering wheel information comes from the machine. It's not available on the anti-collision system, but the steering wheel information and the speed information coming from the machine can be put together with the detection of obstacles of the anti-collision system and provide maximum safety, still providing a lot of efficiency in the production and material handling or agricultural processes. So that again is where the electrification and safety through digitalization paradigms come together and provide maximum value. So that was point 2 of our ecosystem. Point 3, as you might recall, was about process efficiency through real-time locating systems. As I said, our company is very much knowledgeable in technologies and in developing technologies and algorithms that can provide location information. So we use that location information both in an absolute way to provide asset position information, and also in a relative way by measuring distance and relative location of the moving to moving machines, for example, to provide anti-collision, as I just explained. So going back to the absolute location tracking, we can provide real-time locating systems by a third pillar of our ecosystem. Real-time locating systems can provide asset visibility. Asset visibility will improve speed and quality of loading and unloading activities, and generally speaking, of material handling processes, by reducing inefficiencies. And that can be implemented both with a direct location and indirect location, as we will see in a minute. Very quick, at a glance, overview of our locator platform. Locator platform is basically a location engine that will be able to provide the information about the location of an asset to applications, which you see on the top end of the slide, by using technology that can be provided by us, but can also be provided by third parties. And that technology will provide information with many different types of approaches that can be used by locator to compute, calculate, and use the positioning information in order to provide upper layer applications a way to generate business value. We'll see that in a bit, but that's a generic technical architecture that will possibly benefit those that will download the presentation later on. So we're not gonna stay too long on this during this presentation here. So a couple of things that location engines can provide: asset status dashboard and asset search. So you can interact with the location engine to search for assets, and the location information of those assets will come out of the location engine. Map and zone management can also be performed through the location engine. The location engine will be able to use the location information and some logical rules to provide notification and alarms, as well as triggering some events. Example is whenever a product is misplaced, I'll generate an alarm. Whenever a machine carrying some loads will get into some specific areas, I'll trigger an event telling the next stage of the production that for example, the semi-finished product is coming and it's ready. And that's going to be real time and not just based on some information system processes. So it's real time from the field. Same thing, we can do real time and batch analytics. So not only the information of location can be used to provide real time triggering, but also you can collect location information in doing batch analytics, pretty much the same way I've described the near misses statistics on the anti-collision system. So by knowing that a certain process will have, for example, a heat map will show that a certain process is taking place in very specific parts of the warehouse, and most of the operations are going towards that path, might suggest also reorganizing the processes in order to leverage most of the real estate that is available for the warehouse, staying on the warehouse example. And also mapping can be viewed both indoors and outdoors. So that for the technology, but what's the business value of the real-time locating systems? What's the list of pain points in the supply chain? First point is the time wasted on searching for assets. So very many type of industries, specifically in production, assets such as raw material or semi-finished goods are placed in a casual storage way in a warehouse. And when it's time to use them and look for them, there's a lot of time wasted on this. Same thing, identification and routing errors at different steps of the process. So not knowing which product is which and where the product we're looking for is can generate routine errors. A lot of activities that will require manual intervention to scan and trace on products, and generally speaking, the resource utilization will be suboptimal and will miss coordination. The use cases that we can generate with real-time locating systems applied to supply chain operations will generate what we measure between 15 and 25% gain in efficiency. And that's done through four main value levers. One is feasibility. We're able to locate assets and available resources in real time. So we reduce or we make the search time zero. And so the resource usage is improved by devoting resource time to more added value activities rather than searching for assets. Compliance, so we minimize errors. Automation, we automate a lot of tasks. So by knowing which product is which, you don't have to scan and trace those products, and then process optimization and orchestration. As you will see with the fourth pillar, Synchro, the fourth pillar of our ecosystem, which I will drive you through in a minute, we can improve resource allocation by orchestrating the process itself based on location, and also using artificial intelligence algorithms. We have two main ways of providing efficiency in intralogistics in warehousing. One is direct location, so locating assets directly. And the second one is indirect location. So by locating assets, not tagging those assets, but tagging the machinery that will handle those assets and move those assets. So paradigm is this one here. Indirect location of loading unit is provided by locating the machine and then identifying the asset the machine is carrying at a specific time. So the asset is not tagged. You can leverage our TLS without tagging possibly thousands or tens of thousands of goods within a production process, and you just need to tag and to put hardware on the machine that will move those assets, and just automate the asset recognition by very traditional ways, such as RFID or barcode reading or QR code reading. So the benefit here is that the cost of locating those assets is related to the number of moving machines rather than of moving assets, and that's of course again in terms of costs. I'm not going to go through the asset tracking use cases. Again, this presentation will be available for those who can download it later. So in the interest of time, I will just skip those use cases. But we basically, those use cases will define the way that indirect location will provide value on material handling processes. Direct location is basically tagging the goods or the machines directly, and by tagging the exact assets that we want to know the location of. So that's very often used in geographical outdoor areas or or potentially in yards. So we also locate assets in very big yards, for example, in the automotive industry. By tagging those assets, you can know about their location as they move geographically, and you can also inject some monitoring of environmental parameters such as shocks, temperature, humidity in real time, and you can trigger also events or alarms or warnings based on location and environmental parameter status. Again, there's a couple of use cases here, which I will not go through in the interest of time, but people can download them later and go through them. And of course, I'll also provide my contact details, so anybody that is interested in deepening the knowledge of those use cases can also get in contact with me. Fourth pillar is the location-aware optimization provided to WMSs, so warehouse management systems in warehouses. Synchro is the name of our application. What Synchro does is takes advantage of the location of moving machines in a warehouse and it will help intensive logistics operation be more efficient by using the real-time information of the location, of the resource location. The way it does it comes from the fact that we know that even in a very mature and optimized environment, the location utilization is between 70 and 90% in the best case. What those very mature situations lack is the real-time knowledge where their resources are. And a system, for example, WMS, when the warehouse operation plan is prepared, that's done without making use of real-time data. So a plan is perfect, but when it's then executed, there's a reality that differs from the plan. So you have bottlenecks, delays, priority changes, unwanted or unexpected events that can deviate from the original plan. That a traditional warehouse management system cannot take into account, because it will plan based on ideal resources rather than on the real-time resources from the field. I very often make this example. It's pretty much the same way as we used to do a long time ago when we planned for a trip. We would look at a map, either online or offline, and plan a trip, and then execute that trip according to the map that we've seen the day before, or just before leaving. If an accident happened on the road, or maybe traffic jam, so we took the wrong route, then we would still stay on the same original plan, or maybe deviate from that, but just with the map recheck and not in real time. The way that navigators do today, with us moving, for example, in a car, that they will take advantage of the knowledge of the traffic jams across our route or around us, possible dangerous situations, and of course, any time that we will take the wrong route, the navigator will take a new position, wrong position, and will recalculate the best way to destination based on the new updated position that we've taken. So in any single time, the GPS systems that we're using today will calculate our best route to destination based on our location and the environmental situation around us or on the route. That's what Synchro injects into warehouse management processes. It will basically help a WMS do their job, do their planning job, by continuously providing real-time information coming from the field, and helping the WMS take wiser decisions on the next action planning. Let's get in a little bit more of detail here. Synchro will make use of a digital twin, so the power of Synchro is that it can basically define the return on investment of injecting this paradigm into warehouse management processes by calculating the savings that Synchro can provide in advance, so before the installation. That can be done by a digital twin. So it will take the operations done at by the WMS in a traditional way, and we'll try, for example, a month worth of operations. So we'll try to optimize those operations based on location, and will generate the savings that theoretically can be implemented or can be derived from implementing Synchro. The way those savings are generated is by reducing the average time spent per task. Because, for example, to make that practical, if the WMS will plan for resource A to be in AL1 at minute 1, and for resource B to be in AL1 at minute 2, if resource A is late, then the resource B will get there while resource A is still occupying the A. And that's, of course, something that will not benefit efficiency. So what Synchro will suggest at WMS is to reroute a resource B to another task rather than occupying the same A of the resource which is late at doing their job. So that's a very practical example of how things can be improved. And that's, of course, done at a massive level every second for the old maybe 2 shifts or 3 shifts in an intensity logistic situation. So that will provide all the benefits that I was just telling you about by making use of artificial intelligence algorithms. So we're planning in advance based on scenarios that will be derived from the past observation of operations. And so it will provide improvements over time, if I may say so. The nice thing is also the fact that all of this will not only reduce the average time per task, but will reduce the overall distance traveled by machines. So it's also sustainable and will save energy. So I also reconnect to the keynote speech that opened our conference today. Also, another very nice feature is that there's no change in the way the vehicles are operated, because the operators will not notice any difference in the way they carry out their tasks. Yeah, I told you about this, so skip on this. As I said, there's a system modeling. So there's a model of the warehouse. We have optimization algorithms taking advantage of artificial intelligence. It will make use of the locator engine that I was telling you about earlier, and it will use that real-time location information of, for example, forklifts, by providing the next best action to the warehouse planning. And it can, of course, react in real time to context changes as the situation evolves. So you can think of Synchro as something that will take task waves provided at WMS, which you can see on the left, reshuffle those task waves, and assign the task waves in an ordered way to the proper resources on the field. So every resource will get the exact task list, and it can, of course, shuffle that task list over time in order for the operations to be carried out in an optimized way. I will leave this slide for people that might deepen the knowledge of Synchro after the conference. And after that, fifth pillar of our ecosystem is the remote diagnostics we provide. So by our telematics box, we also provide a way to do diagnostics for machines from remote. So without the need of going in the same exact place where the machine is having a problem or it needs reconfiguring. So you can save a lot of on productivity by reducing vehicle maintenance costs and on-site traveling by technicians. So that's basically my presentation. I focused very much on safety and efficiency, but the overall idea is that all of this is provided by digital technologies applied to electrical systems. So all of this is possible mainly on electrical systems that can interact with digital products that provide added value, making use of the data coming from the machines themselves. And that's why this paradigm is very much applied to the future of electrification. With that said, I thank you very much for listening. This is a list of my contact details, and I'm open for a Q&A if there's any question for me.
Thanks, Stefano. Great presentation. You covered a lot of ground. I certainly learned a lot. Thank you. I do have a couple of questions, maybe one from me to get started. As you know, our audience is represented by a lot of original equipment manufacturers in a variety of industrial applications. And they're looking to evolve their electric drivetrains and subsystems. What would you suggest as one or two key takeaways for that audience in this trend line towards digitization and what you're offering currently?
Right. Maybe I'll very quickly go back to the original slide there. I think our approach is, of course, every machine is produced and evolved towards being more productive. Of course, at the same time, safety is a growing concern, and more will define set of rules that machines, the machines that are produced should obey. So our paradigm is to provide a system which a modular system of products that will leverage algorithms, digitization, powerful technologies such as the ultra-wideband technologies that will provide all sorts of added value features that can both benefit the productivity of a machine. Of course, we don't provide any core systems. We're a provider of added value features on a core machine, but those features will make a difference between a machine which is equipped with an advanced technology providing safety and efficiency, and that will make a difference between a machine which does not feature that and a machine that will feature that. Of course, that can be part of a journey, so it doesn't have to be implemented all at the same time. But the interesting thing, especially for OEMs, is that some of those features can be implemented as a standalone slash aftermarket in an aftermarket approach, but it will be even more powerful if they are fully integrated with a core system of a machine. So the example I made about safety is that knowing the steering wheel orientation will make a big difference on an anti-collision system. And that's why, by the way, we patented this kind of approach, because you will make a difference by having this system or any other anti-collision system out there, just because of this integration that I just told you about.
Okay, makes sense. So multiple benefits can be realized by embracing this kind of technology.
I think it's a journey. In a way, it's a journey. Maybe starting from telematics, some of our audience will be already using some telematics systems, some not. Maybe they want to evolve into a more verticalized or detailed telematics system, or maybe they want to move to safety. Process efficiency is something that can be more process or project based, because of course some technology can be made available on the machine, but some of that will be configured based on an end user need. So 3 and 4 are more for let's say for a project with end users, maybe some flagship end users, but 1, 2, and also 5 can also be very interesting for OEMs at this point in time.
Yeah, makes sense. Thank you. One specific question, just from the audience: does Synchro work with manual machines or only with AGV, automated guided vehicles too?
Right. Yeah. You might have seen in the presentation that there's both manual machines and AGVs. But if I had to imagine a situation in which the material handling processes are just managed by AGVs, then all of those deviation from planning or from the original planning are not likely to happen, or at least they just happen in very rare conditions, where maybe a machine is broken or in a situation in which a machine requires assistance. So completely automated situation, then Synchro will add little value. But when there's manual workers around and manually operated machines, or a mixed ecosystem, a mixed system where manual machines and automatic machines are both involved, then Synchro can make a big difference. As I said, we have large clients using Synchro, and we measure efficiencies in a very mature environment. So the environment we found before implementing Synchro was very mature, very modern, but still we're seeing 12, 16, 18, 20% efficiency gains in terms of reduction of operational costs in the warehouse. So huge space for improvement there.
Great. Yeah, that makes sense. We are out of time. Thank you again for the compelling presentation. And for the audience, thank you for attending. You'll see next sessions in the lobby to join. Thank you.
Thanks very
And
much.
you can be contacted. That was the thing I missed. So if people want some initial advice, and they can reach out to you on the contact you've got there on LinkedIn or your direct email. Correct?
Absolutely.
Great.
Thanks, everybody.
Yeah, thank you.